guys, today we are going to do section 4, factoring quadratic equations, and you will be able to factor special quadratic expressions. So a perfect square trinomial is a trinomial that is the square of a binomial. For example, x squared plus 10x plus 25, which is our perfect square trinomial, is equal to x plus 5 squared, which is our binomial squared. So if ax squared plus bx plus c is a perfect square trinomial, then ax squared, which is our first term, and c, which is our last term, are the squares of the terms of the binomial. So in our example, x squared is the square of x, and 25 is the square of 5. Bx, which is our middle term, is twice the product of the terms of the binomial. So bx is 2 times x times 5, which is 10x. B is negative if the binomial terms have opposite signs. So the way we represent this is a squared plus 2ab plus b squared is equal to the quantity a plus b squared. Then if that middle term is negative, that would mean b would be negative in our binomial, so it could also be a squared minus 2ab plus b squared is equal to the quantity a minus b squared. So let's look at a problem. What is 4x squared minus 24x plus 3 in factored form? We're going to do this in one step. We need to think to ourselves, is the first term a perfect square? So we're looking at 4x squared. Is there a term that we can multiply by itself to get 4x squared? The answer is yes. It would be 2x squared, because 2x times 2x is 4x squared. Then look at c. Is the last term a perfect square? Yes. 36 is the same thing as 6 squared. So we're going to put those two as a binomial. It is going to be 2x minus 6 squared. The reason we can do that is because 2x times 6 times 2 is equal to 24x, which is our middle term. Since it's negative in our problem, it's negative when we factor in our binomial. You guys go ahead and try this problem on your own. We also have a special case of quadratics, which is called the difference of two squares. So the name actually tells us exactly what we're dealing with. We're dealing with two squared terms, or two perfect square terms, being subtracted. And we could factor this by the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. When we are factoring difference of squares, we need to use our rule. So what is 25x squared minus 49? So think about, what do you need to multiply by itself to get 25x squared? So it would be 5x times itself minus 7 times itself. And before we said difference of squared is a plus b times a minus b. So here a would be 5x. So we're going to do 5x plus 7 times 5x minus 7. And we have now factored difference of squares. You guys go ahead and try this one on your own, and then you are done for the day.